Forrus is a way
Forrus
to
is
fulfill
a
the
way to
immediate
fulfill
need
the
for
immediate
real-time
need for
monitoring of the
real-time
forest
monitoring of
atmosphere.
the forest atmosphere. It is an AIoT device powered by TigerGraph, Streamlit, and AWS that uses sensor nodes connected to a gateway and a camera that monitors the forest, and if smoke or fire is detected, location is sent to the authorities in charge. The web app is used to monitor the network connections and visualize the data.
Across the globe, climate change has led to increase in wildfire season length, frequency and burned area, causing immense damage to biosphere. It also increases health risks to the locals, and one of the most dangerous aspects of wildfires is their ability to spread quickly and wipe out critical habitat. Wildfires can burn through a forest at a speed of 10 kilometers or 6 miles an hour. Loss of habitat greatly impacts all animals. Species that annually return to the same breeding ground and nesting sites are especially threatened by wildfires. After talking to local forest authorities, I got to know that one of the biggest problems is lack of real-time monitoring of the local atmospheric data because satellite monitoring can sometimes take hours to detect wildfires. When it comes to the control and suppression, time is everything. The more time it rages on for, the more expensive and monstrous it gets. 1 minute you need 1 cup of water, 2 minutes 100 liters, 10 minutes 1000 liters. How it works. Forrus detects fire in two ways. First, each gateway houses a Raspberry Pi Zero, a camera, a smoke sensor, an Arduino that manages the communication between the nodes, and a cellular modem that connects the Raspberry Pi to internet. The camera takes pictures and uses a TA flight model to make on-device classification and detects if there is fire or not. If there is, then an alarm notification is sent through AWS SNS. That also includes a link to view the location on the map. Second, it detects the smoke through the smoke sensors deployed on every node, and each node sends real-time data to the gateway, which sends alarm notification via AWS SNS. Nodes communicate with the gateway via long-range 2.4 GHz NRF24 transceivers connected in tree topology to gateway. Around 5,000 nodes can be connected to a single gateway.
TigerGraph provides an excellent way for forest authorities to monitor and maintain the network and visualize the data in a very intuitive way. To use the web app, you have to enter the credentials, after which you can visualize the network graph overlaid on a map. This allows better monitoring and management of the entire network because we are directly able to see the connections or relationships between the nodes. In the heat map section, we can visualize the heat map of humidity and temperature. And on the last tab, we can see the specific details of each node.
Both gateway and the sensor nodes consume very less power, hence they can run continuously on solar power with a small battery pack. The total cost of making the device prototype after buying everything in retail and single quantities comes to around $55 for the gateway, and nodes cost about $19. This cost will reduce dramatically when mass produced in quantities.